Yeah, okay. So make sure to look at the schedule. So if we go to Blackboard, uh, more people coming in. Or do we? Yep, view all. Okay. Okay, remember in Blackboard, you can always look at the syllabus, the schedule. So if we go down here and look at schedule, uh, it's up to date through the 11th. So, but you can get an idea when guided notes will be done, would do by looking at these dates right here. But so these are the good dates for when everything is going to be due. So, but I'll send out more information, and I'll make sure that I'm communicating with you guys, and that's where we got to be. So, but always ask any questions that you have. Uh, okay. What did I do with my? Got to reload my PowerPoint. Okay, there it is. There we are. You all, admit all. Okay. Oh, there it was. Okay, so we're looking at the PowerPoint. Let's make sure you look at the schedule and always ask any questions. You can call me, leave a message, text me, and hopefully I'll get back to it as soon as possible. Uh, don't hesitate to send me a message. Hey, Dr. Clifford, are you all right? Did you get my message? I'm happy to do that. Sometimes I get behind on uh, messages, but don't hesitate. And if you want to call me, but make sure you put your name in the text and make sure you put your phone number. And when you leave a message, say, this is so and so, and this is my number. Because we all get so many calls on our cell phones that are potential spam or potential block call. So let me emphasize look at the schedule in Blackboard. That gives a good idea when notes are going to be due, when guided notes are due. Okay. So let's talk about the tissues now. Okay, right here. Okay, so uh, tissue level of organization. So there are four types of tissues: epithelial, which is your skin, the lining of your digestive system, uh, lining of glands, connective tissue such as cartilage, blood, bone, loose connective tissue, muscular tissue, which is your skeletal muscles and your smooth muscles and cardiac muscle, and then nervous tissue. So we're going to focus on epithelial tissue. So there are four types of tissue and collections of cells with extracellular material. So if we look at all of the types of tissue that are available, that are used, cover the skin, line the gut and glands. Connective tissue fill internal spaces, structural support, fat stores energy, muscle tissue allows movement of the heart to beat, and also digestive tract movement and mixing of food and neural tissue for it to uh, communicate with the environment and to receive sensory information about are you hot, are you cold, are you in pain, uh, all those things, both input and output of what nervous cells do. So this is important. Epithelium is avascular. There's no blood vessels in epithelial tissue. We'll make comments on that and tell you what's going on. Uh, glands such as sweat glands, mucus glands. Those are all made up of epithelial tissue. So epithelial cells are closely packed. There's a top or apical. So if you look at your digestive tract, the apical surface will be exposed to your lumen of your gut, where all the food starts off. There's a basement membrane, and we got somebody else coming in. So let's admit. Okay. So here we have the apical cells are going to face the lumen of the gut. The skin cells obviously face the outside. Cells are continuously replaced, and they lack blood vessels, so they depend upon the connective tissue below in order to get nutrients and to get rid of waste. So what does epithelial do? Protects you. In your gut, it controls what is absorbed, what is not. Sensation trigger for your skin, sweat, gland secretion, and mucus secretion. Okay, somebody else coming in here. Okay, admit. Okay, back to the power. Okay, some more. Okay, so let's move on. So glands can secrete sweat and mucus, but endocrine secretions such as growth hormone, testosterone, thyroid hormone, those are called endocrine, and those are secreted into the blood. In order to control what epithelial tissue is allowed to enter or not enter, they use these structures called cell junctions. All I want you to know is that the types are gap junctions, desmosomes, and tight junction. So the bottom line is that the cells are held very, very closely together so they don't leak. So just know that there are gap junctions, desmosomes, and tight junctions. And the purpose is to hold the cells together so that they can control what moves across them to get into the tissue that's below them, and also what is produced by them, such as mucus and sweat. Okay, on the surface of cells that are in the gut, for instance, you're going to have microvilli, which increase the surface area for absorption. In the respiratory system, you're going to have cilia. In the tissue that lines the respiratory tract, it's there to sweep out any type of waste or dust or dirt that is being swept out, encased in mucus, and you want to eliminate that. The basement membrane, all I want you to know about that is we go back here. Here's the basement membrane. The epithelial cells sit on this basement membrane, and they're all attached together to have a tight seal. Okay, we got some people coming in. Okay, good. Okay, so back to PowerPoint. Just know the basement membrane is the membrane on which the epithelial cells sit, basically. Okay. Epithelial cells are constantly growing. You know that you have a cut. If you have a cut on your skin, the cells grow back, and you may have a scar, but they're constantly undergoing mitosis to produce new cells. So we're going to classify epithelium based upon whether there's one layer or there's many layers, and cell shape: flat cells, cubic cells, tall columns, squamous, cuboidal, columnar. So pay close attention to this image. One layer of cells is called squamous tissue, cuboidal, simple squamous, simple columnar. So this is found lining your cheeks, lining your all of the membranes that surround your gut and your lungs and so on your heart. If you have stratified squamous, this is your skin, and there'll be differences in whether this is waterproofed or not. In your skin is waterproofed. Stratified cuboidal, these we're not going to worry about much. So you should know about simple squamous, simple cuboidal, simple columnar, and stratified squamous. So if you look at the lining of your peritoneal cavity, all the membranes that surround your digestive system, your heart, and your lungs, it's going to be this membrane made of these flat squamous cells. Simple cuboidal is going to be found in the kidneys as making up the tubules of the kidney. Notice they have a nucleus that is very spherical, and it sits within the center of this cubical cell. Simple columnar is going to be tall columns with the nucleus elongated, and it's going to have tight junctions holding it together, and this is going to line your entire digestive tract from your stomach to your anus. Pseudostratified ciliated, this is found in the trachea and the upper respiratory system, your nasopharynx and so on. But it has cilia. It looks like it's more than one layer, but it's only one layer. So the nuclei seem to be multiple layered, but it's pseudostratified. It's only one layer. So it's found in your trachea. The cilia move to remove dirt, dust, and put them in a mucus secretion and get rid of that dust and dirt. We're not going to worry about transitional epithelium. Stratified squamous is the surface of the tongue, for instance. So the flattened nuclei are up here. So these many layered tissue is going to line the tongue. It's going to line your outside skin is going to be made of this tissue. Okay, so here's the surface of the tongue. It's going to have these stratified squamous. It's called stratified because it has flat cells and many layers of cells that are constantly growing and replaced. Glandular epithelium. All I want you to know is that epithelial makes up glands. I'm not going to ask you about these different types of secretion mechanisms. So again, just know that epithelial tissue makes up glandular tissue, and I don't care about merocrine, apocrine, and holocrine. I just want you to know that glandular tissue is made of epithelial tissue. Now we're in connective tissue. That's a good place to stop. So we'll have about a 15-minute lecture there, and I'm behind in putting up the videos, but I'm working on that. So let's go ahead and go back to, let's turn off the recording for this, so we'll have a separate recording.